Hello, and welcome to today's webinar, Using Intelligent Sensors and Robotics to Change the Material Handling Landscape. My name is Lisa Shaw, and I'll be your moderator. I work on the marketing team here at SICK, and I'm excited to be hosting today's session. I'm also excited to introduce our speakers, Kevin Gagliostro and Brian Duncan. They are going to delve into new material handling applications that combine the latest conveyor and robotic solutions for efficient automated fulfillment. Kevin is a global product manager with a demonstrated history of working in industrial automation. With a background in PLC integration, vision systems, RFID, and various advanced sensors, he has provided expertise to SICK for nearly 2 years. Brian is the national sales manager for the retail distribution market at SICK. With over 20 years of experience, he leads his team to provide unwavering customer support and cutting-edge sensor technology. Before we get started, I do want to share that a recording of this training will be emailed to you following today's presentation. Also, feel free to ask questions at any time during the webinar by typing your questions into the Q&A section on your control panel. And the control panel can be found on the right-hand side of your screen. We'll take some time at the end of today's presentation to address as many questions as time allows. Now I want to turn our time over to our presenters. Brian and Kevin, please take it away.
Hello, and thank you, Lisa. So there's a lot of stuff to go over today, but in the beginning, I wanted to kind of share a little bit about SICK for those of you that didn't know. So SICK at a glance, it is a global company. So if you can see here, just kind of a rough representation. Currently, and growing, there's from product solutions, there's 40,000 plus solutions. And overall, globally, there's almost 10,000 employees. In U.S., we're at 700 plus and growing, right? Another key point to look at here in regards to SICK is the fact that it's a privately held company, which lends way to research and development expenditure at like 10%. So what does that mean? What does that do? Well, at the starting point, where SICK was founded in Germany from Erwin SICK is the first photoelectric sensor, right? In this slide here, you see a lot of firsts throughout the progression of time. And that's due to the fact that, there's a lot of emphasis on engineering development and research and development and continuing on forward. And as you can see too here, in terms of growth and evolution, it's heading towards vision, a lot of vision, and also systems development, kind of like key areas that we'll be talking about today. So if you're to bucketize those components and go to more solutions and or systems and where they fit into ever demanding industrial needs, these are kind of like the key areas that I want to talk about today. So we'll be hitting on those attributes that you see in the box there, which is around detecting, measuring, identification, and robot guidance and vision type elements as well. So the agenda today, I have a couple slides where I'm talking about trends within track and trace or auto ID and trends in robotics and the intersection within, right? And I want to focus on key areas, 3, which is the track and trace systems of which is my charter, BU61 and US track and trace systems. And as part of that is robot guidance systems, and also talking about deep learning attributes and analytics and the intersection of all 3, how all 3 kind of marry up and fit in together. And then we'll close out with kind of contextual use cases around that, right? More specifically, it'll be an intersection of CEP, courier, express, and parcel type use cases, and also in retail and material handling use cases, which is in logistics automation overall, but not limited to that. And then at the end, we'll have a conclusion where we can, if there's any questions, we're happy to answer them. So trends, the first 3 bullets you see there is kind of like what's been happening, right? In track and trace or auto ID, you've seen a progression, starting with 1D, like the most basic in terms of picket fence type barcodes, kind of evolving into higher fidelity 2D matrix codes like data matrix or something like that, right? We have seen and will continue to see, which we're not talking about today, but it's important to annotate, is the intersection of RFID, like in terms of tags and how they fit into a lot of these application themes here as well, right? And as always, there's demands for higher throughput, whether it be reducing the gaps in between the targets, higher speeds, higher read rates, et cetera, and the progression continuing from 1D to 2D to 3D, right, which is more prominent in automation use cases. So track and trace overall, and we'll kind of get into this a little bit more, the systems, we kind of think everything's centric to the conveyor, but we're not limited to the conveyor. And also the evolution of the conveyor is changing. It's becoming more and more dynamic. Case in point, like a roller top type conveyor, or conveyors that are smarter, or conveyors that are tailorable based on ever-growing application themes, right? In terms of personnel, you see the evolution, which we see in some of these pictures here of people now going to cobot or collaborative, and eventually, potentially, for certain facilities and distribution centers, is the light. There's no personnel around, right? And a lot of the things that is driving that is, labor shortages, right? You see in Amazon, for example, there's never need for more help, more people, just due to the shift in how things are working in e-commerce, but also specific qualifications to be able to fit into those spaces, and wage increases are also driving that, and hence the introduction of robotics, right? Robotics is continuing to grow, and there's a lot of robotics themes that are showing up, whether they be collaborative, standalone, or AMRs, right? You can see here in the picture below, these are kind of the key areas like collaborative, cobot type, AMRs, which is AGV, AGR, AGC, standalone, standalone here with the typical robot arm, or a conveyor-centric robot arm that has the conveyor moving underneath. Today we'll be talking or focusing on the collaborative and the standalone arm type applications, right? And also sensors, there's ever demand, and sensors are becoming smarter. Sixth core competency is the sensing, it's the data harvesting, right? But there's a lot more information that can come out of that information that's coming from the sensors for analytics, information go to the cloud, and so on. And we'll be talking a little bit today of some of those attributes around analytics and deep learning for detection, segmentation, classification, inspection. So a snapshot in time that I actually found this online. Here's the source. It's actually a good article. But in 2017, there was a characterization of growth in investments towards robotics, which was roughly about $50 billion US, right? And it was essentially bucketized into 5 different areas. I just wanted to kind of get across between software programming into robotics, robot accessories and the vision systems, services around it, and safety around it for the cobot and collaborative. SICK has invested in all these things. We don't have the robot arm per se, or the robot, the AGVs, AMRs, but we have the components that fit into this, and we integrate quite well from a system look, right? So the next piece I wanted to talk about, you can actually go to sick.com and see, which is actually organized quite nice, is you can go into the industry segments, go to the certain focus areas. As you drill in, you can see the serial components and the system offerings within. So for track and trace and auto ID, at a very high level, you can see it pretty much is in everything in regards to factory automation and logistics automation, hence the blue, right? Not to say that it's not in there, but for the areas that are black, but for my focus area, for the business unit that I'm in, the track and trace systems that I touch are kind of the blue areas. So what is track and trace, right? Fundamentally speaking, in its most simplistic state in my mind, you have packages or targets moving down a conveyor or in motion, right? You're essentially tracking where is it going and where has it been. And and what you're tracking are certain attributes around that target. In this case, it's a barcode, right? And we can kind of get into other things as well. But that's essentially what you're doing, is trying to harvest that information. So this is what I call kind of the trinity, if you will, the technologies that lend way into the auto identification or track and trace application of themes. You have laser scanner, right, and all the serial components that are tied to that. RFID, whether it be HF, UHF, ultra wideband, et cetera, right? And then on the vision side, the camera side, is the two 3D components to also harvest that information. Right. So now let's talk a little bit about the targets, the progression of 1D to 2D to 3D, right? So 1D, if you think about it, typically like a laser scanner. You see here in the look here, that's what's called like a picket fence. You essentially are looking at a barcode and you want to scan it in motion to get the whatever the code is, the information that barcode represents across. You have to sweep across. Right? Graduating to 2D, now you're kind of looking at an XY, which is like a data matrix type effect. You get the same information, but it's more camera or vision centric, right? So progressing in the evolution as well. Now we're kind of going into 3D, where you would actually would want size, width, volume, shape, dimension type information, right? So talking about the attributes around the targets a little bit, right? So the 1D to 2D to character recognition, verification, and RFID tags, you're essentially trying to identify something, whether it be 1D or 2D. What does it say? The license plate information, serial number, et cetera, et cetera. That's part of your track and trace. Things are evolving now more into also being able to contextualize information beyond what's in that tag or what's in that code about the box or the shape of the object itself, right? Or if these things aren't even there, maybe you just want characterizations of an object itself. Dimension, weight, where, what. In this case, if you look carefully here, you would want to know specifics about this object features within the bin, what the orientation is of it, so you can properly pick it, right? And you can train to specific features around that, size, feature, dimensions, et cetera, right? And also weight is another one that we look at. So this lends way to the track and trace systems. So SICK is, now that we're talking about all the sensing components that we have, so our solutions, our systems are very tailorable. It's based on whatever application theme that you care about. So in here, you have essentially the brains, the computation or the PLC, and the Rolodex of whatever sensing elements based on your application theme that you care about, right? And on the software side, you can do deep learning, analytics, take information to the cloud or to the middleware and or enterprise level at that facility. So going back to the trinity that I talked about before, the core themes in terms of auto ID or track and trace, you have they're based on what it is that you're doing in your sample set or your application theme. You would want a laser, maybe you would want a camera, right? Or maybe you would want RFID. And here's a look as to differences of why you would use one over the other, right? Like for example, for a camera tunnel, it's also highly future-proof. You can do a lot of analytics around that. You have the vision type information. RFID, and a lot of times, you would have a mix of both in terms of vision and RFID. There's a lot of targets or things inside of that pallet or inside of those boxes that you can't see because you're obstructed by the box itself. So RFID helps with that. Another good use case around that is a mix of both is in airport for baggage, right? You see in terms of the bags that you have, there's a mix of vision for the tag that you have on your bag, and also it's embedded with an RFID UHF antenna, so you can actually look at both. So at its core, there's kind of what I call 5 key areas for track and trace or auto identification for systems. And we're going to go a little bit deeper on the intersection of these two, right? But as a, you have 1D, 2D vision type, like the lector or camera-based solutions. You have what I call static. It's not in motion, but you're looking at weight, volume, dimensioning features, right? And systems thereof, and dynamic. Also RFID, which we just talked about. And today, as I said, we're going to go a little bit deeper on these, the intersection of vision and robot guidance via the arm for certain application themes, and how it could potentially marry up to conveyor or KEP or logistics automation, retail, et cetera, types of application themes. So on the robot guidance side, there's a lot more SICK offerings of which that I'm going to talk about today, but I want to focus on ones that intersect into kind of conveyor or logistics automation themes, right? So at the bottom, you have the Plock 2D, which is a 2D belt pick. We often say that that's kind of like an automotive factory automation type accounts, but it's conveyor centric. And, there's some kind of robot pick element that's in play there. But it's essentially, if you look in this look right here, you're exploiting 2-dimensional features of a target, right? Because that's essentially giving the robot and the end effector coordinates of how to pick that thing up and put it into the next thing, right? The PLB is kind of the same mindset, but it's more of a 3-dimensional point cloud. I also want to call attention to the fact that PLB is part localization and bins. That's kind of a misnomer, right? As a starting point in its infancy, we talk about bin pick types of use cases, but it's not limited to that, right? It's actually piece pick. It could be for palletization, depalletization, conveyor pick, right? And we'll talk a little bit about those today. But if you see in this look here, that's actually a bin and pick type application, which is also more so like in factory automation. So talking about being scalable, like talking about the targets themselves, you kind of get a feel for, so an automotive industry segment or factory automation, those to the left there, you get a feel for the target type themes or the bin pick applications. It doesn't necessarily have to be from one bin to a bin. It could be from one bin to a conveyor and so on. To the right, kind of getting more into logistics automation, like courier, express, parcel, UPS, FedEx, DHL, retail, storage, and conveyor. The targets kind of change. The mix changes a little bit. It's not like high featured, like where you're reliant more so on a 3D CAD model, as you see to the left. It could be something a little bit more simplistic if it's a bag or a box or, pieces that you see there, like pallet and so on, right? So that's something to think about. So our PLB portfolio, kind of broadening this a little bit, the epicenter is what we call the PLB engine, right? This is the common portfolio or the common platform, the brains, this is the software, right? But I'll talk about this a little bit more, but it's technology device agnostic. So there's a chance, and we'll show the 3, and also moving forward with the technologies that we have, the different component types, it is very feasible and possible. And on our roadmap, we're going to do this is put more of the components that we have into this PLB engine based on what the use case is, right? Also, I'm going to talk about this a little bit more. We're not limited to the algorithm type or the plugins. It's tailored to what the application theme dictates, right? So we're not forcing you into having to buy everything. It's tailored to what your requirements are. Also, as an output, we don't care about the end effector, what's picking, right? We train to whatever's out there based on the application theme, and we also are robot arm agnostic, right? We have comms modules and programming that can fit into whatever your requirements desire, right? And an output of this, we call these things right here in the upper right systems, but they're really not. they're really components with software, but where it's heading into that we're going to continue to develop is pre-engineered system theme kits, whether it be bin picking, palletization, depalletization, or piece pick via sortation, conveyor, et cetera, et cetera. And and there'll be variants within those standard concepts, right? So it's highly scalable and tailorable to that. And as part of that, there'll also be, which we also have and will continue to evolve, is programming that are tailored to those application themes around it. Right. So getting into the technologies a little bit, I don't want to harp on this a little bit too much, but it's based on the requirements of the application theme and the sample, right? So the way we do it is whether it be simulation or actually physically testing with the specific object that's in play or variants thereof, right? It could be multiple objects within the conveyor and the bin. Is there's a decision or an output. Being technology agnostic is to choose the optimal technology. We don't care. If it's the PLB 500 that's based on laser triangulation, the PLB 520 for active structured light, or possibly the PLB Visionary S, they all have certain attributes and cost points associated with them that's good enough, right? So PLB 500, PLB 520, like one telling thing that you can tell the difference between, you see these a lot in factory automation. This one is really good for high fidelity, high featured, right? But if you have highly reflective surfaces, it can be problematic. So you may need to use the PLB 500, which is based on laser triangulation. The Visionary S is for higher throughput, higher speeds, but it's lower resolution, which actually could work better, is better for KEP and or retail if you're looking at boxes and bags and envelopes. So drilling in a little bit more, I was talking about algorithms and plugins. I don't want to get into the details too much, but if you look to the left, this is kind of 3D drawing based, CAD based, more in factory automation, where you're actually training to a lot of details and features within that offering, right? There's a different price point associated with that. But we also have, as part of that PLB engine, is this may be overkill for certain application themes to where we have plugins. These are a sample set, like flat region, circular, predefined box, where you're looking at specific features as part of that plugin, and that's all you need to tell the robot arm and hand effector of the coordinates and how to pick it and where to pick it, right? This is just a sample set. So the plugins, there's actually more, and that will continue to grow as well. All right, so transitioning a little bit more into deep learning, right? So this is kind of like more on the analytics software side. If you look to the left here, so deep learning, the center circle, it's kind of a mix of, people talk about artificial intelligence, machine learning. It's additive. The outcome of all this is deep learning. If you look carefully to the lower left, each bubble, in my mind, is a representation of certain features or attributes that you put into a model library or an archive, or you train to it about features about the box and the bag, to where it's a looking point. So when you have that 2D, 3D sample set view, it will bounce it against what's in the model library to decide percent likelihood of classification in this case, if it's a bag versus a box, right? So there's other attributes. So what I just talked about is what we call classification, but there's other things you can look at in terms of detection, segmentation, anomaly detection, and so on. And I'll provide further context on others. But let's go back to the sensing technology a little bit, right? So what I just talked about there in terms of deep learning, right? So progressing back from 1D to 2D to 3D, you know what I mean? So it depends on the technology. On the 1D side, maybe you're trending change in velocity over time, right? But in 2D, right, in this case, in this example, if you look carefully, you have a bounding box, right, of what the overall length width dimensions are of the box. You can get the code, the barcode, the information, and also where that resides in space relative to the box. And progressing more into 3D, you have point cloud, where you're essentially, this gets more into robot guidance, not to say that the 2D doesn't, but you look here in the bin pick in terms of retail as an example, to essentially hand off the coordinates and the information, in both cases 2D and 3D, but how to pick the robot arm to pick that object or do what it needs to do with it, right? So here's some back to the classification theme that we're talking about in deep learning. This one specifically, you can see at the bottom to the left, here are some key attributes, that you may want to characterize or look at. On the demo that I'm going to do today, I'm going to talk about what's in the box there is bag versus box. It's called SIV, single item verification, or single object versus multi-object detection, right? And kind of to get a feel for use cases around that. But you can also look at other things as well. Is there a packaging strap, presence of a tote? In retail too, there's, you can also characterize certain features around the target. You can train to whatever application theme that you care about, right? But these are just examples. So SIV, single item verification, or single object detection versus multi-object detection. So here's kind of like different points that you can train to in that model library, right? And the different poses and kind of the nuances around it. But as outcome, those little bubbles that we talked about before in terms of your library or your model look, it'll give you, it'll essentially the probability of single object. Is it a bag? Is it a box? Multi-object, right? So that's an example there. And also here you can see too, in the demo I'll show you in a little bit, this is one of the systems that we have, the ICRA 90-4. So this is kind of a KEP point of view, in terms of packages. But this is an example of these are certain attributes that you can exploit and compare to, right? The blue box is what I'll show you guys is box versus envelope or bag, right? But there's other attributes you can exploit and do the probability, against this white box versus brown box, certain shapes around it, and an envelope, right? And lastly, we'll talk about this a little bit today too, and the use case is dangerous goods detection, or hazmat. In the lower right here, you can see from that model library standpoint, here's all kinds of different looks to train to from an imagery of dangerous goods and the labels that are on there, right? You can see in the picture here, as this thing goes down line into the conveyor, is you would want to isolate or say, does that box, is it dangerous goods? And downstream from a sortation standpoint is to put it onto another conveyor, isolate it. Maybe you want to pick it off the conveyor and put it elsewhere, right? But based on the deep learning, you can actually exploit those attributes. So here's kind of a use case. We actually moving forward. We tried doing this at MODEX this year, but we weren't there. But for PAC Expo and future MODEX and a lot of these events, you'll see this and probably iterative improvements thereof. But this is kind of a snapshot in time of what we did the last few months, right? And I'll show a video, but this talks about from a track and trace systems or auto ID, there's the ICR 890-4 tunnel system that we have that looks at, the bag box, like, whatever features are there. And it's 2D, right? This one in particular actually has, I didn't put it there, has an LMS, which actually does, you can actually get 3D information as well, right? If you look carefully in this picture here, the robot guidance theme that I was just talking about, there's the Visionary S, which is one of those 3 products that we have as part of the PLB Studio. And there's also, in this case, it's being robot arm agnostic. We have the UR5 robot where it's actually doing a bin pick off the conveyor and actually placing them on, right? And the deep learning attributes that I just talked about for classification of bag versus box, multi-single item verification, right? And dangerous goods detection is all in this use case. So I'm going to bring this up real quick. I'm going to jump to about the 20-second mark. So if you imagine, there's a box and a bag on the conveyor, right? So from start to finish, the ICR kicks off, scans, takes a look, and I'll drill in on what these are showing here. But on the screens, there's some of the deep learning attributes of which we just talked about that I'll talk about a little bit more. There's PLB Studio, which we can show live as to what's going on there from the snapshots that the Visionary S is taking of the various pick poses from conveyor to telling it where to have that end effector pick the bag versus the box and put it in its associated bin. Today I'm not going to talk about it as well, but there's a lot of package analytics there too that gives you information about the box and bag and the targets that are on the conveyor itself. Right? So drilling in a little bit more, you can see, so as the box and the bag sweeps across the conveyor, there's different looks, probability of bag versus box. In this case, it's pretty much saying that it's almost a 1 that it's a box, right? In the beginning, you just miss it. There's also single versus multi-item verification. In that picture, obviously, it's telling you that it's a 100% probability that's a single versus multi-object, right? In the beginning, you can see that it's actually saying it's almost 100%, like a 0.999, that it's multi. There's actually a bag and a box, right? So that's talking about those deep learning attributes. PLB Studio, I'll show you that as well. And I have another demo here. We can see it a little bit more. So at the end, the conveyor itself is triggered off of photoelectric to stop, but the Visionary S. So now if you imagine from a handshaking standpoint, the information, in this case, it's kind of a little bit segregated. The Visionary S doesn't necessarily need some of this information or attributes, but where this is evolving is SICK as a core competency. We have solutions upbound or downstream and upstream on the conveyor, right? So now if you imagine some of these attributes being exploited and shared to the robot arm piece, right? In this use case, what's happening is the information I'm telling you about. Oh, and by the way, in that picture there too, I meant to show you guys this. In the picture there to the left, there was also the hazmat or dangerous goods detection. So in this use case theme, what's happening here is the information that's being shared and going to the robot arm is saying, okay, well, the box, if you imagine this as the hazardous goods bin, it's telling it to pick that and isolate it and put it in there, whether we're saying it's a box-themed bin or a dangerous goods bin. And the other bin is envelopes only, right? So you can get a feel for how that information is shared and how that's of value. So a couple other use cases, and I'll be sure to make sure that this is all shared, but there's actually some demonstrations on retail-centric use cases for pick, right? And these example set, we have pencils and batteries. I'm not going to show the full YouTube videos, but we have links to that. Nick Longworth, who's actually on our systems integration group, he actually made these, and he has does a demo. They're 4-minute videos, so they're quite long, but there's narration on both of these use cases as to what's going on in the various aspects, right? So you can imagine here, so for pencil pick in retail, right? So this is the PLB Studio, the PLB engine itself. In this case, this is using the PLB 520, right? Every now and then you'll see a flash, and it'll actually update to the left, essentially the new pick pose, and it's giving you the object that is saying it's the best candidate for the end effector to pick, right? So that's what you're seeing. So it gives that information to the robot arm with the coordinates, et cetera, to essentially go get it and then put it into the other bin, right? So in this use case, it's a pencil pick. And I'm at a high level, I'm talking about this, so I highly encourage you guys to look at the video. It gets really into the details of what's going on in PLB Studio and you know, some of the features within. Similarly, there's the battery case pick, right? So in this look here, you know, part of PLB Studio is the end effector. In this case, it's a suction cup, right? The pencil pick was a slightly different end effector where it had a gripper for the pencil. So in this case, it's actually just picking up via vacuum against the packaging for that battery type. So you get a feel here. So it's got the coordinates of that in the studio, and it's telling it essentially the coordinates and orientation of which object to pick based on that update information, and it actually goes through. You'll see here in a second, the UR5, you see the flash, it's going to actually update what you see in Visual Studio, and it's actually telling it what to do based on what's in Studio, and it'll go do it, and then put it into the other bin. So like I said, all these videos, we'll figure out how to make sure to share these, and there's, you know, this is posted on YouTube, and it's quite informative, 3-4 minute videos. So now I'm going to hand this off to Brian to kind of talk about retail application themes, right? And to further kind of contextualize how you would use these technologies and systems within that industry segment. Want to take it, Brian?
Yep. Thanks, Kevin. So we've looked at some cool technology today and some things that are fascinating in their advancing technologies and developing technologies. But many of you may ask, why is this important to me? Well, it's important because these technologies enable robotics. They enable to be fast, efficient, robust, intuitive, and affordable. And just a few short years ago, you really couldn't check off all those boxes. But we're kind of at the current state where deployment of robotics and logistics is becoming normalized. Kevin, you can go ahead and advance. So logistics operational needs are exploding. I think we can all agree with that. They were already growing prior to this COVID-19 pandemic, but now those needs have been amplified exponentially. So there's a huge challenge, right? Sourcing, hiring, retaining a labor force of the magnitude that's needed to support this growth is highly challenging and enormous. So we want to find ways to automate labor-intensive, repetitive tasks and mitigate this labor resource challenge. We've continued development of these kinds of technologies to the point where this is now more possible than ever. And what I've done here is added a couple of application examples that we see in logistics. There are a lot more, of course, but these are some that have become more prevalent the past few years. And all of these are enabled by vision technology. For example, you look at palletizing and depalletizing with a robot. This has been going on for a number of years, but now it's more highly dynamic and more flexible and more resilient than it used to be. Whether it's palletizing or depalletizing, the ability to discern items and their state is much more robust than it was prior to now. Anybody who's had one of these systems recalls that you have to have an individual in the area all the time to go correct errors. Well, the errors have been greatly reduced through the improvements in the vision systems. Go ahead, Kevin. In fulfillment operations, we're seeing the use of robots begin to increase quite a bit. The slide that Kevin went over a couple of minutes ago, which showed the picking of pencils and battery packs, is the kind of discernment of items that you need to select for each picking. And you can see there's a couple of applications here. One is feeding a sorting robot that will then take the item to either a tote or a shipper container to be sorted. On the right, you see really a pick to put wall solution that is also being deployed in the marketplace. And again, the vision technology has improved so much that now the speed at which you discern the item decide which one to pick, and relay that back to the operator, the robotic control system, is much greater than it's ever been. Go ahead, Kevin. To continue on the theme of piece picking, which you see quite a bit of in e-commerce, on the left, you see actually, many of you are familiar with the term goods to person workstation for picking. This is actually a goods to robot picking workstation. And again, the technology that we make and provide enables this to take place. On the right, you see a mass flow belt robotic pick application, and vision is very critical in this one to be able to decide what am I going to pick and where am I going to put it. And you can put it into a carton or a case or a sorting device. Go ahead, Kevin. And then one that's it's a highly repetitive job is placing items from, let's say, a bulk pick bin onto a unit sortation device. Very repetitive. I don't want to call it mindless, but this is going on 24/7. Having a robot do much of this work is a real advantage and mitigates the cost and the labor needed to do this. So you see the robot on the left is picking up a garment in a bag, and it would place it on what you see here is a cross belt sorter. It could be a tilt tray sorter or any other unit sorter. But that helps mitigate quite a bit of the labor factor in automated operations. So yeah, those are just a few applications we wanted to show you that we see that we're working on right now with integrators and OEMs to bring to fruition in the marketplace. And they are just increasing in number and scope. This slide here shows where you can go and find more information about the core themes we discussed. All of these are through a link. Encourage you to go and explore these sections that are on our site, and let us know if you need any assistance.
Yeah, and another thing here to add, and the look you guys see in the upper right, there is a repository on SICK.com for on-demand webinars. So there was talking about the PLB and the PLB engine. This is an example of how you would use or add in plugins versus the CAD algorithms of localization and or edge detection, right? I believe there's also a PLB overall webinar as well. It'd be in the same place. So if you kind of dig in, you can find saved webinars such as this in that location.
Thank you, Brian and Kevin. And we'll go ahead and take some questions. As a reminder, you can type your questions into the Q&A box on the right-hand side of your screen. And we haven't received any yet, Brian and Kevin, so if there's anything else you want to mention, go for it.
I think it's just a recognition of the explosion in robotics in logistics automation and retail distribution in general. Many of the things that we see used to be only on the manufacturing floor in automotive manufacturing and other heavy industry. But the adoption of robotics and the use of things like AMRs in distribution is exploding right now. So we're being constantly asked to collaborate on solutions. Again, we're the enabling technology. So you can have a really nice robot arm that's robust and beautiful and works really well, but if you can't see what you're doing, it won't do you a lot of good. And that's where our technology comes in, this type of technology comes in.
As a reminder, a recording of this webinar will be sent to you following today's presentation. A copy of the PowerPoint deck I would recommend contacting Kevin and Brian for that information. Typically, we don't send out our decks. One question came in, and the question is, when using the SICK systems, how are the SICK systems communicating and compatible, with hard, maybe I should start again. How are the SICK systems communicating and compatible with warehouse management systems?
Yeah, most of the time that our system is going to probably communicate with an integrator's controller or an OEM's controller. Although we do have customers that are asking us now to provide data to the cloud, and we are able to do that. Through these types of systems that we're talking about today, that they normally go back to the robotics controller or a WCS provided by an integrator.
Great. This question comes from John, and he asks, do you find the logistics industry is prepared to maintaining the cobot technology?
That's a great question. Very good question. In a typical distribution environment, the answer is no. As we know, when you go to a very standard conventional mechanized distribution center, your maintenance capability is, the investment in maintenance capability is not that high. I'll say it that way. Where we see the ability to maintain these things is in customers who have already adopted more highly automated systems. And they typically have more highly trained mechatronic type personnel on staff. And they could certainly be trained to be comfortable working with this kind of technology.
Awesome. And the next question is how is the deep learning process? Do you have to prepare thousands of good images for the first setup?
Yeah, Brian, I can take that one.
Okay.
So the model library that I showed is yeah, to your point, it's the right way to do it to assure closer to 1 or 100% success is for that specific site or account to train to the sample set of which it cares about, right? So the model library at the core, there could be some bubbles that I showed that are predefined, but over time, like based on certain accounts, it would be really good to train to those target themes to assure optimal success, right?
Awesome. Those are all the questions I see. So if you have any that you think of later on, feel free to email Kevin and Brian. And Kevin and Brian, is there anything else you want to add before we wrap it up?
We appreciate everybody attending. We're happy that we didn't have to show our faces on video because we haven't had that in 6 weeks. But we thank you all for attending and encourage you to email us and ask us anything, and we'll be glad to help you out.
Awesome.
Yeah,
Thanks, Brian.
Yeah, thank you very much for your time.
Awesome. Thanks again, Brian and Kevin, and we hope to see your listeners again soon.
Okay, thanks.